Students, very good morning. Student, we have ended our topic standing wave and stationary wave in open organ pipe as well as in stress string. So both the topics we have covered now. So let's see now the second application of superposition principle, that was beats. Like when we were discussing that how many applications of superposition principle are there, in that one we have to study only the three applications here. The first one was standing wave, second one was beat, and third one was interference of light, or interference of exactly waves. So let's see the second phenomena, what is beat and how we can produce the beats. Like in music industry, number of times you have just listen this word, beats word. So exactly what is the meaning of beat in the terms of science? So you can see, as or you have observed that when two sound waves that have equal amplitude and nearly equal frequency, now you have to understand in different phenomena what are the properties of the wave. Like in the case of standing wave, the both of the waves that have same frequency, same amplitude, and one wave was incident, second wave was reflecting wave. But here the two waves that will superimpose over each other, and two waves are sound wave now, first of all, that one, and they will superimpose, and obviously their property is that there should be slight difference in their frequencies, not equal frequency, slight difference only. So here, if they will travel in a medium along the same direction and superimpose over each other, then intensity of resultant sound at a particular position rise and falls alternately with time. So this alternative variation in the intensity of sound with time at a particular position when two sound waves of nearly equal frequencies and amplitude traveling in the same direction superimpose over each other is called simple beats. So it means, in beat phenomena you are seeing at some places the frequency starts to increase and at some places it start decrease after the superposition of the wave. So if now you will see intensity of sound at t is equal to 0, that is maximum value at t is equal to 0, and one beat is said to be formed when intensity becomes maximum again after becoming minimum once in between. So it means now continuously minimum intensity, minimum, maximum. In this pattern we are observing the variation in intensity here. Now the time interval between two successive beats, that is the two successive maxima of the sound where the two successive maximum intensities point, that is known as beat period, and the number of beats produced per second is known as beat frequency. So here example is given, and you can easily understand the beat phenomena by using this example. For first example, when two sound waves that have very close frequencies, suppose the first wave has frequency 256 hertz and the second wave has 260 hertz, that reach our ear simultaneously. So we hear a sound of frequency 258 hertz in place of the two frequencies 256 hertz and 260 hertz. Means we are seeing or listening the average frequency of them. So which is simple average of two combining frequencies. In addition, the frequency of sound heard increases and decreases slowly. So the number of beats produced per second is equal to 4. So which is the difference in frequencies of the two incoming sound. So here we are just listening the maximum minimum intensity due to the combination of these two sounds, and that is for only 4 numbers of beats only we are listening, that is always equal to their difference in frequencies. Now it is saying why nearly equal frequencies for beat, why this condition we needed here. So for the formation of distinct beat, frequencies of two sources of sound should be nearly equal, that is the difference in frequencies of two sources must be small, say less than 10. Means maximum the difference can be 10. This can be explained here on the terms of properties of persistence of hearing exactly. So the impression of a sound heard by our ears persist on our mind for 1 by 10th of a second. So if another sound is heard between that 1 by 10 second, then that time impression of the two sound mix up and our mind cannot distinguish between the two, and that time we are listening the average of that two. So in order to hear the distinct beats, time interval that should be between two successive beats, that must be greater than 1 by 10 second. So therefore the frequency of beat must be less than 10, so that we can distinguish the two sound waves. So that here it means that the number of beats per second, that is the frequency, that must be less than 10 here. So this is, now you can see the two sources should be of nearly equal frequencies. Now the next one, here let's see the formation of beats here. For the formation of beats, first graphical method is used, and for that graphical method, two fork we are going to use here. Tuning fork, these are used to produce the sound, and later I will show you the figure of that one also. First let's start here. So suppose we have two tuning forks A and B. Let the frequency of first fork, that is 6, and frequency of the fork B be 8. For example, let this one. Now let the wave of compression and rarefaction, as the sound wave is longitudinal in nature, so compression and rarefaction it will have given by the fork. Now A and B be represented by the curve A and curve B respectively in figure 15.33. Here you can see the first figure, that is this one. In this figure, this is for the tuning fork A, that is producing the frequency, and here for that one the wave is generating. Similarly for the B, the tuning fork B, it has this one case. Now let's see again what it wants to say. Again in figure 15.33 C, so superposition of the two waves from fork A and B, and we have represented the resultant wave according to the principle of superposition. Let's see that here, when these two waves will mix up, and that time they will start to form this kind of resultant wave, because they have different frequencies, so they will exactly mix up here in this way. And you can also see that at every position the difference in frequency is obtained in between the waves. Now the final wave you can see here, after the mixing of these two waves, the final wave will have this kind of just nature, and it means it will contain those two waves and its superposition within a packet, and in this way it is moving in forward direction. So here this was the graphical treatment, and you can understand this graphical treatment at t is equal to 1 by 4 second. And similarly this one is very easy to understand, you can understand by all. What we will discuss here that is analytical method, because this method is completely based on the mathematical method, so we will just go for that one. Now in the case of analytical method, let us consider we have two waves, wave train of same amplitude but slightly different frequencies. So suppose first wave has frequency nu1, second wave has frequency nu2. Now that is traveling in a medium in the same direction. So let the time dependent variation of the displacement due to two sound waves at a particular location be. Here first one is represented by S1. So as we know the relationship for the sound wave, that is the first one r sine omega 1t, as both are moving in the same direction, so no need to represent plus kx here. So we can write only S1 is equal to r sine omega 1t. That also can be written as r sine 2 pi nu1 into t. Similarly S2 we can write in the terms of nu2. Now let's apply the superposition principle at the time t. So that is saying S is equal to S1 plus S2. So both are moving in the same direction, so algebraic sum will be obviously positive. So we can write down this value, and now we can write down this one. So then after this one sine 2 pi nu1 t plus sine 2 pi nu2 t. Now you can see this is sine c plus sine d. So we can now apply the formula of here sine c plus sine d, that is also written here. After applying this formula you can get this one whole of the resultant, that is 2r cos pi nu 1 minus nu 2 t sin pi nu 1 plus nu 2 t. So finally S is equal to, you can write A sin pi nu 1 plus nu 2 t, where A is what? That is the amplitude of the wave, and that has value 2r cos pi nu 1 minus nu 2 into t. So this is here clearly representing the resultant amplitude A that will change with time. So whenever time will change, according to that one, the amplitude will also change, and as amplitude will change, then intensity will change. So this is now the process to understand the beat phenomena. Now amplitude, you can see from here, that will be maximum whenever this value will be maximum. So cos pi nu 1 minus nu 2 t, that will be maximum, means that will have the maximum value plus minus 1. And if you will write the general value of for the cos, then that will be cos k pi, where k will have value 0, 1, 2, 3, 4 and so on. So here from here you can compare these two lines, and we can get this one, pi nu 1 minus nu 2 t is equal to k pi, or finally t can be calculated from here. So the time we can see now, so we can understand from here when we will get the maximum frequency. So you can see now at here, from here, as k has value 0, so if you will put 0, so at t is equal to 0 you will have maximum value. If k is equal to 1, you will put this value, you can get k is equal to 2, 3 and 4, so on. Means at every this time, after every this time, we will get the maximum intensity in the sound. Now next one, the time interval between two successive maxima, that is called beat period. So that can be calculated by just taking difference of any two difference you can take, and that will be equal to this one, 1 upon nu 1 minus nu 2. So from here, as you, this is the beat period, and you know the frequency is reciprocal of beat period, so frequency of the maxima will be this one, that is nu 1 minus mu 2. You can see now here the frequency generated, that is the simple difference of the frequencies. Now let's see what will be the time when we will get minimum intensity. So the amplitude that has value 2r cos pi nu 1 minus nu 2 into t, that will be maximum when cos pi nu 1 minus nu 2 t, that will have the maximum value, that is the 0. So here for that case, as you know, cos theta is equal to 0, then we can write its general value, that is cos 2k plus 1 pi by 2, where k again it has value 0, 1, 2, 3, 4 and so on. From here you can calculate again the value of t, so that is obtained in this way. Now you can put the value of k is equal to 0, 1, 2, 3, 4 for understanding when you will get the minimum intensity. So at these times you will get the minimum intensity, and again you can calculate the time period between or beat period between two successive minima. So that is again the difference of the two times here, this one, or this one, anyone you can take, and that will be again same as before. We have got the time beat period for the maxima, and again frequency is same. So it means the comparison of t values for maxima minima intensity shows that maximum and minimum intensity of sound occurs alternately. Alternate means once if we have got the maximum intensity, then again we will get minimum intensity. I think this up to now the beat phenomena is clear. Here the experimental demonstration of beat, that is also given. So let's see how can we demonstrate. Here the figure you are seeing, A and B, that is the tuning fork that I was just wanted to show you. So here, to demonstrate the formation of the beat experimentally, we take two tuning fork, A and B, exactly of same frequency. So mount the fork on sound box and place them so that upper ends of the box face each other. Now here you can see. And the next one, attach a little wax to the prongs of the fork A. So prongs, this section is known as the prongs of this fork. Now on these prongs of the fork A, set again fork A and fork B into vibration. By vibrating them, then you can clearly hear beats. means the frequency of the two tuning forks you can hear, because the second one B that is not having any kind of wax, so the frequency variation will be greater, and means that will be near about the variation in that one, that will be greater, and that time we can distinguish that distinct clearly, because reason is that here the first frequency and the second frequency produced by A and B, in that one the time to reach at our ears, that is greater than 10 1 by 10 seconds, and that's why we can hear that one. So next one here, but if you will change the amount of wax, then that time number of beats per second that starts to change. So at some stage when amount of wax is such that the frequency of the two fork differ by a number greater than 10, then beats can no longer be heard separately. Now application, let's see where we are using the phenomena of beats, and just now I have told you the music industry, in that one we are using already. The first important phenomena is here, the phenomena of beat is used to determine for the determination of unknown frequencies. So if suppose we know the frequency of the tuning fork 1, that is new one, we know that one, and we know the fork B produce m beats per second, because that we can count easily by experiment, but we don't know what is the frequency of the fork B. So we can calculate the frequency of fork B by the formula, that is nu 1 minus nu 2 is equal to plus minus m. By using that one concept you can easily calculate now. And here the positive and negative sign, how can we decide that? The frequency can be, if there is the difference in the frequency is 4, so it means if first one has frequency 260, then second one can have two possibility, that can have the frequency 264 hertz, as well as that can have frequency 256. So which of the frequency will be the exact frequency, how can we decide it? So that is, for that one we are doing first experiment, that is by loading fork B with wax. So if suppose frequency of fork A is given here 256, and it gives 4 beat per second with fork B, so two possible frequency, just now I have told you like that 260 can be, or 252. So if we will attach a little wax to one of the prong of the fork B, it becomes heavier, so that its frequency decreases. So say to 259 from 260, or 251 from 252. Suppose one value decreased here. So the sound of the loaded fork B with fork A, and count the number of beats. So if the frequency of fork B were 259, so number of beats per second should be here 3, because the first one has A has frequency 256, so the number of beats will be produced there. The variation in maximum and minimum intensity, 3 times you will see listen at least maximum frequency, so that we should be 3. That is if here it should be less than 4. Now if the frequency of the fork will be 251, then that time the number of beats should be 5, that is greater than 4. So in that way, by just counting the number of frequencies, you can conclude whether the sign will be positive or negative. So this is now the way here in which very easily we can calculate the unknown frequency. Now next one here, the second application you can see, that is phenomena of beat is used in radio reception in many ways. In the designing of low frequency oscillators, beat are used. Phenomena of beat is used in detecting the presence of dangerous gases in mines. Now one sample problem is given here, let's see that one also. A tuning fork of frequency 2 Hz is in unison with a sonometer wire. So how many beats per second will be heard if tension in the wire is increased by 2%? So here what are given now in our question. First N1 is given. N1 is what? That is now the frequency of the tuning fork. This one is given. Now the time period, that is T1 is given. It is now 100 units. So and T2, that will be 102 units. Reason is that it is given that the beat per second that is heard in the tension of wire, that is increased by 2% exactly. Not this is, I think, here the tension in the wire first, or tension in exactly tuning fork, that is suppose 100, then that time the tension T2 will be 102 units because it is increased by 2% here. Now, as we know here how the frequency and tensors are related to each other, and that is now the directly proportional to each other. So, n2 upon n1, that can be written as t root of t2 by t1. Now you can solve this equation and you can find the value of, first of all, n2, that is again obtained as 202. And now you can see the variation in n1 and n2, that is 2. So number of beat produced per second, that is 2 here exactly. Next topic, students, let's see, that is the Doppler effect in sound. Here as three types of applications we had to study, that was beats, standing wave and interference. So why we are not studying interference here? Reason is that as in class 12th, interference of light in a very detail we will discuss there, we will study there, that's why we are leaving that topic from here. So let's start to discuss the new topic, that is now the Doppler effect in sound. This is the new topic. What is this one now? So as here you can see the definition. First of all, that is the Doppler effect is what? Whenever there is a relative motion between source of sound, the listener, and the intervening medium. So the apparent frequency of sound heard by the listener is different from the actual frequency of sound emitted by the source. This you can experience in your daily life also. Whenever you are approaching to any sound system, you are just finding out the frequency of sound is going on increasing, and when we are just going away from the sound system, then it is going to decreasing. Then wind system, if intervening medium means the wind is flowing, suppose, and that wind is flowing in the direction of sound, then up to some greater distance we can hear that one. But if wind is flowing in opposite direction, as we are standing, then that time we are not listening up to that distance. So this is all factor that is changing the frequency that we are hearing. We are not hearing actual frequency, we are hearing apparent frequency. So this is impact of the change in frequency because of the relative motion of intervening medium, relative motion of observer, relative motion of source. That is known as the Doppler effect in sound. Simple one. So here now you can see some examples are also given here, like the frequency of whistling engine heard by a person standing on the platform appears to increase when the engine is approaching the platform, and it appears to decrease when engine is moving away from the platform. The second one is the pitch of the horn of a motor car appears to increase when the motorist approaches the policeman, and it appears to decrease when the motorist is moving away from the policeman. Now thus basically Doppler effect, you can see, that is related to the motion and that change in the frequency of sound. Now next one here, one thing you have to note, Doppler effect is essentially a wave phenomena. It holds not only for the sound wave but also for the electromagnetic wave. So that's why in your next class you will also see the chapter Doppler effect in light also. But up to this syllabus, as in pandemic time, that is deleted syllabus, but you can study that one in the same way as we are studying here. Now let's see the expression for the apparent frequency here. Today I will just give you the glimpse for this one. Later in next class we will discuss in very brief here. If we have to find out the expression for the apparent frequency, here you can see a figure for that one. We have seen S is the position of the source, L is the position of listener, Vm is the velocity of medium. Now Vs is velocity of sound, V is velocity of wave, Vl is velocity of here listener. So this is all the things that are that is just given here. Now next one thing, when this source is moving, then obviously after some time it will be at the distance S dash, and if the listener is also moving, it will be at the distance L dash. Then if the whole of this thing is moving with velocity v, then how can we understand the
variation in the frequency. So you can see this relationship here, equation number 88, the final relationship we will get here. So the final here expression for the frequency we will see by this equation, equation number 88, you can see now. So this will be obtained in this form. So let's see its derivation in next class, that is here. We will just go for tomorrow for that one. So up to now, I think students, the most important thing, that was the superposition of wave and the phenomena possessing by that one, that I think that is now clear, very clearly to you. And here with this topic our chapter will be ended. So I think up to now all the things that we have discussed, that is completely clear to you. So let's end our discussion here with this one. Thank you students for today.